Hello guys, now I am going to discuss another very complex or very interesting topic in modeling and simulation, that is random variate generation. For random variate generation we use a simple technique in mathematics, that is inverse transformation technique. So inverse transformation technique, we can implement this in the following ways: uniform distribution, in exponential distribution, variable distribution, and triangular distribution. Mainly I focus into form uniform distribution and exponential distribution. So uh, so here I'm going to discuss about exponential distribution in this video, and uniform distribution I will make another separate video for that. So for exponential distribution, we use just simple formula, and I will discuss how we can generate that formula. So for exponential distribution using inverse transformation technique, we use here, if the probability distribution formula is given as for fx is given as lambda multiplication with e ki power minus of lambda into x, will be when x is greater than or equal to 0 or 0 otherwise. If other case, then it will be 0. So respective CDF for that we can write as fx is equal to 1 of minus e ki power minus of lambda when x is greater than or equal to 0 or 0 when other, then that case. So our purpose is to generate x1, x2, x3 and other random variate using our exponential distribution formula. So first we have to just find out that what formula we can use here. So for that I am going to discuss in step by step process. So for process 1 we have to just compute CDF, so which is fx is equal to 1 minus e ki power minus of lambda multiplication with x, and in step 2 we have to just put this value is equal to r. So if we put fx is equal to r, so this value will be equal to this one. And now in step 3 we have to solve the fx value with r, and we have to find out that what is the term value of x. So when we equate these values, so the e ki power minus of lambda x is equal to 1 minus r, and when we will take log, so we will get the value of x is as x is equal to 1 minus of lambda multiplication with log value of 1 minus r. So here so in simple terms we can also write x value as f inverse r. So in step 4, to generate r1, r2, r3 and and corresponding xi using the formula xi is equal to f of inverse in r, as r is uniformly distributed, so 1 minus ri can be simply written as ri. So we use simple formula, that is xi is equal to 1 of minus of 1 upon lambda multiplication with ln of ri. So we use simple this formula to implement to find out random variate generation using our exponential distribution. Okay, so now by using one example I am going to discuss how we can find out these values. So if the question states that using our exponential random variate generation formula we have to calculate random variate for the random variables, these ones 0.1306, 0.422, 0.6597, when the lambda value will be 1. So I will discuss how we can use our random how we can get our random variate using our exponential formula. So for that we have to use simple formula. So here xi is equal to 1 minus of 1 divided by lambda and ln in bracket 1 minus ri, where xi is equal, what is xi? Xi is random variate and ri is random number, and we can simply also use this for lambda is equal to 1, then we will get xi is equal to minus of ln ln in ln of 1 minus ri, where I is equal varies from 1, 2, 3, 4 and 5. So this table I have prepared where Ri denotes random number and respective random variate is denoted by xi. So for Ri is when the I value will be 1, we use our simple formula, that is xi is equal to minus of ln of 1 minus Ri. So we will get respective xi value is for random number 0.1306 we will get 0.1399, and for second random number 0.0422 we will get 0.0431, and for third one we will get 1.0779, and so on. So this is the simple implementation of our exponential random variate when lambda is equal to 1 in inverse transformation technique. So this is how we can calculate our random variate for x1 and x2. Just I want to show you that when we take minus of ln 1 minus 0.1306 we will get 0.1399, and for x2 we will when use minus of ln 1 minus 0.0422, so we will simply get 0.0431. So this is a simple calculation of mathematics. We can calculate this one. So this is how we can calculate x1, x2, x3 and x5 and respective random variate using our exponential random variate generation technique. So this is the end of this video. So thank you very much for watching this video.